Good morning and welcome. Today we're going to look at how we can create shapes in Java. We're using a little bit of a different version for this. So we're using, again, Eclipse to make this, and we're using Java to create the shapes. So we can actually create an art-based project using a little bit of a abstract modern art to do some with this. And so we're going to go ahead and take a look at our art panel class. Our art panel class is where we're going to be doing the work for this. We could potentially think about using a special little utility class to do this and have some static methods, but I like having an object that can handle the things that it needs to do, so we're going to use it with that. We have right here a couple methods we're going to be working with. We're going to start off with our coinFlip method. Just a quick way to get our coinFlip method. It's a quick way to get a fairly random Boolean value, either true or false. We can use it to do different versions of where we're going to skew or scale our value that we're attaching to our points that we're going to be creating these points, our shapes with. And so using math.random times 2, which is going to give us a value of either 0 or 1, because we cast it right here as an int. And if it's equal to 0, we return true. If it's not equal to 0, we'll return false. Really pretty easy. We then have our createPolygon method. Now, in Java, we have an interface called Shape that is the structure for all the shapes we'll be working with. And so we're going to be using the createPolygon method to create our triangles and any polygon that has 5 or more sides. And we'll take a look at how we're doing that later on. But we have right here a sides parameter, as you can see, that's going to take that and returns a polygon type. And this is a specific shape. We'll be working with a couple other shapes as well. But the polygon shape, we're going to start off with triangle because triangle is pretty easy. And so we automatically pass it 3 because 3 is the simplest shape. And so what we do is we can make a brand new shape, and we set an origin point for it. And we're using math.random times 600, which guarantees that this point that we're picking on is going to be somewhere between 0 and 599. So we can easily find it inside the bounds of our panel that we're drawing this on, which is a 600 by 600 image. And so that gives us an origin value, and that's going to be some point within that range where we're going to have an x and y. That's our origin point that where we're going to start drawing for that shape. Then we're going to use the magic power of a for loop. Oh, yes, I know. And we'll start an index off at 0, index is less than size, and index goes up by 1 each time. And this is where we're going to actually, get however many sides we need to create a point, get how many points we need to create a shape or polygon based on whatever we're passing as a parameter. And so we're going to use a new thing, something we haven't seen in our class so far, right here on this line 151, where we're using coinFlip ::. Whoa. This is a brand new thing. We haven't covered it before. This is the ternary operator. It's called the ternary operator because it has 3 different values it works with. It has the equal sign, the question mark, and the colon, and it has 3 different sections: the condition, the value of true, and the value of false. And this is a great way to have some simplified code. I only like to use it on really simple, easy, tiny things because it can only assign into a variable. And so in this case, it's minus. And so minus is going to get coinFlip whether or not it's true or false. If it's true, I'm going to give it -1. If it's positive, if coinFlip returns false, however, I'm going to assign 1 to it. And then I use that right here in the next line, 152 and 154, which is going to tell me where to put the next point that I'm creating. So I use that origin point right here, but this next point is going to be based off of that origin point. And so my shift x is going to be int again. I'm going to take math.random times current scale, and current scale is some specific value we have as a constant defined in the class. Current scale is a variable that we've used from some slider that is defined by the user. And so whatever the user has selected as the scale, I'm going to use a random factor on that so I can actually get some scale factor attached to that times minus. So I'm going to go up or down on the shift x. I'm going to go left or right. If I have a minus, obviously I go left. If it's a positive, I'm going to go right because I'm going to increase the value greater with that if it's a positive value. And then I'm reassigning to minus because, again, I want to have this be somewhat random. Again, coinFlip plus or minus 1. Because if it's, and then I'll shift it again. And then my shift Y, I'm going to go big, going down the screen, or up, going a minus, go up the screen. Because again, the top left corner is 0, 0. A little bit different, not quite Cartesian. And so I'm going to grab in that same approach where math.random times current scale and multiply that by minus. So am I going to shift that? And I'm going to repeat that process over and over again. So if it's a triangle, I get 3 points. If it's a nonagon, I'm going to get 9 points. But I keep grabbing those different points. And because of the fact that I'm not doing anything special with this, we do have the chance of getting a non-convex shape, aka a concave shape. So we'll have things that could point into itself. We'll worry about that later. But then grabs those things, and we use this magic thing called addPoint. The addPoint line right here is where I'm going to take the origin x plus shift x, and if shift x is a negative value because of that times minus, it moves it over. And then we have the origin y plus shift y again, which possibly shoots it up or down depending on what kind of value we get in the minus itself. We're going to get a collection of points based on the current scale and some random value attached to whether they're going up or down, left or right on that. And that point gets added to the shape that we're working with. And so we have however many sides we're going to put on that structure, we add that many points. Really pretty easy. And then once I'm done with that, I return the current shape. And so I create a bunch of shapes as needed. This is going to be inside a GUI panel because, again, this is an art panel, so it's part of the GUI, so this is being handled by a button action. Our createRectangle method works much the same way. Our createRectangle, again, creates a java.awt.Rectangle because it's the rectangle shape that we'll be drawing inside this and using the abstract windowing toolkit. With a rectangle, however, we don't just get 4 random points. With a rectangle, we want to start with our top left corner, and that's why I named the variables corner x and corner y, because it refers to the top left we're going to start attaching this to. And then again, I'm giving that top left corner x and y the same approach, where math.random times 600, because my image is 600 by 600, so I have that information right here. Possibly could make a better value and actually have this be so it would be attached to a constant for the class. Might be a good class redesign issue to work on later, but we'll take care of that another time. On the width one right here, we're going to set the width of the thing, of the rectangle, to be corner scale plus 1. So I want to always make my width be at least 1 big. So because math.random could give me a 0, and I really don't want 0. And plus current scale, so what are my current scales? So I want to add 1 bigger than that. So I automatically, if that math.random is a 0, I always automatically have a 1 because I could get something with that. And then if coinFlip, again, we're using that coinFlip method to go up or down. But this time, if my coinFlip returns true, I want to be able to make a square. And so my rectangle constructor takes the corner x and corner y, and then takes a width and a height. And if it's a square, I'm just going to use that same value for width I just have, and that'll be my width and my height. Wow, easy square. If it's not returning true, then I'm going to set my height to be a new random value. Again, current cell plus 1, so I actually have at least a 1 by 1. So theoretically, I could still get a square, but yeah, no worries there. And then my current rectangle is a new rectangle, again, passing it corner x, corner y, the width of that rectangle, and now its height, which could be, hopefully, different than the width that was supplied earlier. And then again, just like that, I return my current rectangle. The same basic approach happens inside my createEllipse. However, ellipse is a bit different as a structure. So my ellipse 2D is the class that we'll be using for this, but notice on the constructor right here on the right-hand side of line 183, I have my ellipse 2D is the type I create, but it's a new ellipse 2D.double. Because ellipse 2D itself is just an interface. The .double is where I get the actual class that goes along with that, and it's of double precision, excuse me. So we have that right there. And again, just like a rectangle, I get the top left corner of x, y. And again, I'm using that same basic approach. Wow, really easy. And then my width, again, is the same approach where I take the random times current scale plus 1. And it's a double, so I don't have to do the parens to catch it and turn it to an int to make sure, because it's a double value. And then if coinFlip, I'm going to set my circle to be a circle, because width and width will be the same. If it's not, then my height is now math.random times current scale plus 1, and that whatever that is, and that will be now my oval section, so I have a height attached to that, and again, I return that. So creating an ellipse, not really that much. So I have 3 different shapes that I'm creating: ellipse, rectangle, and polygon, and based on those structures I create, it's going to give me some values. Now, these are part of the actual art panel itself, and we'll take a look and see how to use that in the next video. And so all we've done right now is done this structure to actually create those 3 different shapes, or 4 different shapes actually, because we're keeping triangle and polygons as their own separate thing based on the parameter we're sending to it. And so we'll take a look at how we use that in just a bit in our next video. Thanks and have a great day.